So I went through the tomb site, found Bernd's photo, and say, okay, I will work with him.
Which crashes before the other team's bridge, then we have a winner. If not, then we have a fantastic situation where you are just a gigantic, super performing team. All right.
Nice to see everyone, and I wanted to say a little bit about some methods of working that we could use in this week, and also maybe to contrast a little bit with how those methods might be applied in other places, what might be relevant here, what might be relevant in other places, things people do, things we might not want to do.
Miro is technically just a whiteboard, the digital whiteboard as I presented.
So our next step is to understand what the problem we are trying to solve.
Kirill calls them subteams. I call them also services. From a system design point of view, these would be services offered by all the other teams. Then I'd like to introduce Professor Vivian Lofnis.
This talk is focused on sustainable and smart and resilient and healthy cities. So it's literally trying to tackle 3 goal statements: how to add technology, how to ensure that the city has a long life, to make sure it's resilient in the face of climate change, and to make sure it's healthy for the residents. That's all the criteria that you might think about for smart cities.
As we have just seen, we booked or successfully reserved a parking spot.
That it is near, it will turn right to pink. It's okay, it's okay. Sometimes it happens because of the hardware. It's like, for now, I can help them.
Web cameras already in use, the one here.
All our system is centered around the MQTT broker.
Only reason to use it for us right now was abstract.
Not with a very good resolution or something, on purpose, because we want to use low tech.
There are some minor or major, depending on the point of view, technical problems.
I could just start by describing the kind of task that we identified.
So I would say a couple words. I will repeat it in my presentation, but I feel that this kind of spirit quite unique for education. And switching to the official part, I would like to welcome everybody and say thank you for people who and companies actually who support us. This is JetBrains, this is Leptas Group, this is Webtoon. So we had big support from universities. So this is London Imperial College, this is Carnegie Mellon, so TUM and Neapolis University.
Thank you so much. So perfect transition, I would say, just because we have a little overview of like how international our team is, even just from the university side as well. Let's dive a little bit into the problem we actually want to solve, right? Smart city. So we actually want to focus on transport solutions. So what could we talk about the transport solutions? Just in general mobility, but we wanted to focus a little bit more on mobility hubs. So what is a function of a mobility hub? One is mixed mode transportation. One is intermodal transfers, and then also the possibility to charge. And this all moves basically into the concept of mobility as a service. We've seen the vision. What's actually our solution? It's Apollo, and it's the autonomous parking orchestration with large language outfit.
In the system, we have a dashboard, which is the place that the city manager can see what's actually going on.
So the parking garage team focuses on two tasks, which is car detection and parking guidance. So we currently have two different systems to detect and track the vehicles. First is OptiTrack. The OptiTrack system is a bit complex and also too expensive for everyday use. And therefore, we have created another system, which is based on cameras. Currently, our system utilizes one webcam, but it also supports multi-cameras if needed.
And now we're going to talk about how we're actually able to drive cars autonomously and how we're going to control the robot arm. And Sasha will talk about you with that.
So we have a DakiBot. As you can see here, it has a camera, it has a lights, it has a license plate, and battery and CPU. We are using this bots to go through the parking zone and park near the April tags. Also, we have a robotic arm. The robotic arm has 4 different parts that can move separately. That's why we can move as we need it.
Yeah, we'll talk about how we actually implementing a bidding and scheduling system for parking spots.
The price for each parking slot during each amount of time is not fixed, and it is decided during the bidding process.
Now we want to see how everything is done with the demo.
I want to introduce first the city manager.
Hello,
Hello, is this the city manager?
Yes, that's right. How can I help you today?
Well, I'm looking for a parking space. Can you help me with that? I need to park and charge my car near the city center from 5 to 7 p.m.
We have an available electric parking space in Leda Garage. Priority charging in this spot is auctioned with a minimum price of €1. How much would you like to pay for this parking space?
Well, since it's scarce, at least €10.
We successfully booked your parking space.
Somewhere in a garage, in a certain place, and as the light turns to dark blue, it seems that... Yeah! So it found the parking spot, and it's now parking. Yeah. Like implemented the garage, the parking. Wow. I was wrong. Yeah. Starts to move in it.
Also, we have this this parking cage that is managed to move the car drives safely. Yeah. The car will be driving, maybe it will be driving faster, and we will have this system better. So it sees the parking spot, and it understands that it can park, and will try to go into the parking, the parking spot with this parking spot. So it will help a bit in the car. Yeah. So. And the lights will follow this car to the certain place. Sorry. I moved it and it was my fault. And the lights are following the car to show it the right place to park. Yeah.
We have it mapped into our digital twin, which is available on the screen. You can see how we track the ducks. The ducks represent the robots, they're called ducky bots.
Okay, I would say this was a great demo with all its potential that you showed us in a few engineering problems with the Natasha Touch, and now it's actually working. So I'm impressed. But I still like to say, with a round of applause for the team, thank you very much for being here. And may the future be with you. Thank you very much.